Introduction to Organic Chemistry, multiple choice questions. There's a lot in this case for this topic, about 26, so I'm going to have to speed it up. I probably won't be able to go through all of the questions in detail, but that's fine because I'll be also going through the multiple choice questions again, and maybe end of this month, maybe next month. Question 1, which alkene shows EZ isomerism? So we look at 4-methyl-pentuene, methane, ethane, propane, butane, pentane, pentuene, methyl group and a fourth carbon. And you can see that this will show EZ isomerism. Question 2. Which is the correct mechanism for this reaction? Okay, so 1-bromopropane with potassium cyanide. This is obviously going to be nucleophilic substitution. NS, nucleophilic substitution. I already know that the Cn minus ion needs to be negative, Cn minus ion, so it can't be A and it can't be C because the Cn doesn't have this negative charge. So I'm left with B and D. Now, what's the difference between B and D? There we go. It looks like the difference is that all they've done is instead of going like this, the curly arrow just goes like that. No, but if you pay even more detail, in B, the lone pair of electrons come from the carbon. In D, the lone pair of electrons come from the nitrogen. Where is it supposed to come from? It's supposed to come from the carbon. And the correct answer is B. And that's the trick for that question. Question 3. Which compound has a molecular formula that is different from the others? Now, what I would say is, obviously, if you work out, you don't even need to work out full names. If we can look here, that's 1 double bond, that's 2 double bonds, right? 2 double bonds. 2 double bonds. Double bonds. That's 1 double bond. This, well, that also causes you to lose 2 hydrogens. The reason I'm talking about double bonds because therefore you lose 2 H's, 2 hydrogens. In this case, you have this cyclic structure, and you're also going to lose 2 hydrogens. And in this case, you've got 1 double bond, therefore you're going to lose 2 hydrogens. Where if you look in this case, that's got 2 double bonds, therefore you're going to lose 4 hydrogens. Therefore, A is going to have a molecular formula that's different from the others. That was just a bit of a tricky question. Question 4. Which compound has EZ isomers? I really like this question because it's just testing your knowledge on this. Obviously, I've got to have the 2 carbons groups got to have 2 different functional groups attached to it. Now, if I look at A, CH2, and then a HBr, these 2 are the same functional groups. Therefore, it's not going to show EZ isomer. It's not. It doesn't have EZ isomers. If I look at B, same thing. CBr2, CH2, 2 of the same functional groups on the carbon. No. Same thing with D. I've got Br2, Br on one of the carbons. No. Therefore, the answer is C. And the reason it's C is because, yes, I have HBr on one side and HBr on the other side, but there's still 2 different functional groups attached to one carbon. So in this carbon has 2 different functional groups, H and a Br, and this carbon has 2 different functional groups, H and a Br. Even though they're the same, it just matters that they're both different. Whereas in A, you got hydrogen, hydrogen. In B, you got hydrogen, hydrogen, Br, Br. And D, you have a Br, Br. That's not going to work. Question 5. Which is the correct general formula for non-cyclic compounds in the homologous series? The answer is A, alcohols, because alcohols, obviously, is CnH2n plus 1OH, right? Learned from ages. From, I think you learn it GCSE chemistry as well in triple. And therefore, all that they've changed is that hydrogen go there, so that becomes H2n plus 2O. Therefore, the answer is A. Question 6. What is our IUPAC name for this compound? This one's a bit of a tricky one. First thought, even myself, I'm like, it's not going to be A because I've got 2 methyl groups. So it's going to be B. 2,2 dash, because look, 1, 2, 2,2 dash dimethyl 3 fluoro methane, ethane, propane, butane, pentane. It has to be B. But remember that IUPAC name needs to be in alphabetical order because I've got a methyl group and I've got fluoro as well. Alphabetical order, and A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So F becomes before P. So F becomes before M in the alphabetical order. Therefore, it must be C. You need to say the fluoro first. Question 7. Which compound has the lowest relative molecular mass? Ethanoic acid, CH3COOH. 1-fluoropropane, methane, I'll just draw out methane, ethane, propane. So it should be CH3, CH2, CH2F. Propane, nitrile should be methane, ethane, propane. You've obviously got a nitrile group. So CH3, CH2, CH2N. Propyl amine, you've got your amine NH. And you've got your propyl group CH3, CH2, that's ethyl CH2. So it's going to be CH3, CH2, CH2, NH2, I think. But once you work out, then you just work out relative molecular mass of each one, and you should find that C, propane nitrile, has the lowest relative molecular mass. This is going to be a bit annoying. Which one has EZ isomers? Again as last time. We'll look at the first one, H2Br2, C2H3Br, that's definitely not. C2H4Br2, no, that is going to be A. Question 9. Which compound is not an isomer of the following compound? Now this one, if I look at this one, we're not an isomer. A definitely is. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. A definitely is an isomer. B, yeah, the answer is going to be D. Not an isomer of this. Question 10. Which does not contain an asymmetric carbon atom? Asymmetric carbon atom does not contain it. Answer is going to be A. I'm probably going to have to rush through these now. How many isomers? C3H9. Just draw all the isomers and you should find out that are 4 isomers of C3H9N. There we go, now it's back to normal, but you can just flick through like that. How many structural isomers of unbranched carbon chain has a molecular formula C4H8Br2? Same thing you do, and you should find out that it is C. Which statement is correct about the molecule? It reacts with HBr on electrophilic substitution reaction. No, it doesn't. No, it does not. It does not react with HBr in electrophilic substitution reaction. HBr, hydrogen and bromide, that would be electrophilic addition reaction, not electrophilic. No, it would be electrophilic addition. Yeah, it'd be electrophilic addition, not substitution. It reacts with NaBH4 in a nucleophilic addition elimination. No, it reacts with NaBH4. Remember the H minus ions in this case for this mechanism, and this is a nucleophilic addition reaction. It reacts with ethanolic potassium hydroxide in an elimination reaction. Ethanolic potassium hydroxide elimination reaction. So it's not A and B, or B. Both of them are wrong. Elimination. No, we won't. The answer is D. Question 13. Which can both be proton formula and molecular formula of a stable compound? Now already I can already see it's not going to be B, that's P for O10, that can be simplified to P for 2O5. Left with A, B and C. Now CH3 is not going to be stable because remember carbon can form 4 bonds, right? So that's what it's going to want to do. Same with NH2. NH2 form NH3 with NH4 plus ion. Therefore the answer must be A. And that makes sense because CH2O think it's like that. If it is, that is a way more stable compound compared to NH2 and CH3. How many structural isomers? They always like asking this question. Draw structural isomers, you should get 5. And you know what? I don't even think, that you even need to know about structure. Well, you obviously should. You probably obviously do, but only questions I've seen of structural isomers are the multiple choice questions. But you just ask you how many structural isomers there are of that. Yeah, they might also add in a couple of others, but yeah, they always like to ask that question. In question 26, which of the following is general formula of cyclic alkenes such as cyclohexane? CnH2n minus 4. You can quite easily do this just by your knowledge of all of this. CnH2n plus 2, that's alkanes, not cyclic alkenes. CnH2n, that's alkenes, not cyclic alkenes. CnH2n minus 4, I've never heard of that. It's CnH2n minus 2 because you've got the double bond, therefore you're just going to lose 2 hydrogen atoms. So, yeah, hydrogen atoms. So CnH2n minus 2. So you do it minus 2. Question 25. How many secondary amines have the molecular formula of that? Again, you just do that and you should get 3. Question 24. How many structural isomers have the molecular formula C4H9Br? The answer is 4. Like, I've seen so many of these type of questions now. So, again, a very similar one to that. How many isomers have molecular formula C5H12? The answer is 3. Just draw them out. And okay, before I even carry on, what I'd recommend is, when you're on the multiple choice section of the exam in chemistry, put your hand up, ask in the exam hall, ask for spare paper. And because a lot of these multiple choice questions, obviously you've got the ones that involve numerous calculations where it's like it's a one marker, obviously all of them are one markers, but it's got like multiple calculations to do. Those ones are they aren't too difficult. These ones where it's about mechanisms and also about structural isomers, you can ask for scrap paper, and so you can just jot them all down and then you can get the answer. Instead of doing it on your exam paper, it's just gonna be more time consuming. And so as soon as exam starts, you just ask for paper. Yeah, you'll waste like maybe 30 seconds, but then trust me, you probably will not regret having that much paper to use. Which is a pair of functional group isomers? A, definitely A. Functional group isomers? E. Functional group isomers. Yeah, definitely A. Again, testing your knowledge on isomers. Question 22. This looks like a very unique question. Z-retinol in the diagram, shown in the diagram, is a component in vitamin A. Like, we don't even need to know that. Which of the double bonds labeled A, B, C, or D is responsible for the letter Z in the name? Oh, actually, we just need to know Z-retinol. Which of the double bonds labeled A, B, C, or D is responsible for the letter Z in the name? C, definitely going to be C. Z-retinol. Yeah, C. What is the total number of structural isomers molecular formula of that? Again, just draw them out and you should get 4. I'm only left with 4. Which compound does not show stereoisomerism? I've gone through this question before, I can remember. So, yeah. The answer is obviously not going to be A. It's not A or B. No, it's not A or C. I'm left with B and D because both of those are alkenes that obviously going to, and they've got two different functions. They've got the functional groups attached to it, so they're all going to show stereoisomerism. If you look at 1,2-dichloropropane, methane, ethane, propane, chloro on the first carbon, chloro on the second carbon, that will show stereoisomerism because it's a chiral carbon. One methyl group, a hydrogen, a Cl, and a CH2Cl. So those are 4 different groups, therefore it will show isomerism. And A and C, I'm pretty sure one of them doesn't have a chiral carbon. However, just because it doesn't have a chiral carbon doesn't mean it can't show stereoisomerism for alkenes. But for alkanes, if it doesn't have a chiral carbon, it's not going to show stereoisomerism. And if you look at D, methane, ethane, propane, 1 chloro, 3 chloro, fill in the hydrogens. Yeah, it's clearly not. These two are the same, and so is this and this. So that will not show stereoisomerism. Question 18. Which curly arrow does not appear in the mechanism of this reaction? In concentrated alkali propanone reacts with hydroxide ions to form an equilibrium mixture shown. Equilibrium. This with a CH, that definitely will happen. It definitely will appear because then one carbon double bond. Now I'm left with B, C, and D. C bonds to the H plus, and then that. D definitely will happen. That makes sense. That's why the oxygen could have the negative charge. I'm left with B and C. Well, in B, it's telling me it's going from a double bond to here. And then that's why this has got the double bond and that's not got it. That's not going to appear in the mechanism of this reaction. Question 16, which is which compound is structural isomer of Z-butyrene? Z-butyrene, E-butyrene, right? No, let's draw out Z-butyrene. Methane, ethane, propane, butane, butyrene. Actually, we need to do it like this. Methane, ethane, propane, butane, butene, C4H3, 4, 5, 6, 7, 8. Perfect. Carbon, double bond on the second carbon. Now, which compound is structural isomer of Z-butyrene? So Z-butyrene, they're on the same side. That's how well, that's just an acronym to know it. So on the same side. Yeah, so perfect. They're on the same side. So which one is the structural isomer of it? Butane, ethane, propane, butane, ethane, propane, butane, C4H10. Oh no, E-butene. So they're enemies of each other. So all that's happening is this is going here and that's going here. So now they're opposing each other. That's not a structural isomer of it. Not going to be butane or E-butene. Cyclobutane. So cyclobutane. That will be a structural isomer of Z-butyrene. Cyclobutane. C4H8. Yeah, because butane is C4H10, but because you've got this cyclic structure, you're going to lose 2 hydrogens, therefore it's going to be C4H8, and because it's a different format and it's got the same number of molecules as Z-butyrene, is going to be a structural isomer of that. And methyl butyrene, no. So the answer is obviously C. Question 15. Which is the mechanism for this conversion? This one is tricky. Nucleophilic addition elimination, electrophilic substitution, free radical substitution, nucleophilic substitution. Addition elimination would never happen with this kind of. Would never happen like this. No. Electrophilic substitution. Remember electrophilic substitution? The nitration, all of that. That's also not going to happen with this. I'm left with free radical substitution and nucleophilic substitution. It does look like it could be nucleophilic substitution because all I've done, as you can see, that stayed the same, that stayed the same. All I've done is replace the group from CH3 to CH2Cl. No, but the answer is actually free radical substitution. And that is 15C. And that is the end of the multiple choice questions.